Hello and welcome to my presentation for the virtual event of the 2020 European Polar Science Week. My name is Steven, I'm a PhD student at Alfred Wegener Institute and I'm working in the project led by Daniela Janssen, who is also working at AVI. And the title of my talk is Folded Ice Stratigraphy in North East Greenland, a three-dimensional structural analysis. And our motivation is the question if we can actually learn from a 3D reconstruction of radar stratigraphy something about current and past configurations of the ice sheet. And the tool that we are using to investigate that is airborne radar data with AVI's ultra-wideband radar. The study site that we are investigating is located in northern Greenland, and we have a set of 12 radar profiles, which are in a region where ice thickness is between 1.5 and 2 kilometers. The westernmost profiles are located very close to the ice divide, where ice flow is almost zero, and the easternmost profiles are located in a region where ice flow is about 15 meters a year, and the general direction of ice flow is from west to east. Image B shows a bit the local topography, and on image D we can see the velocity gradient, which is very, very small in that area and means that we don't have any relative movement of ice on the surface at least. So this is how the radar data looks like. We have 12 profiles. These profiles 1 to 6 are the westernmost profiles, and we see that in these profiles we have much less deformation than in the eastern profiles, and we also see that we have 2 large folds that we could image, and from these folds we did our surface reconstruction, and we did it the following way. We traced internal layers that were close to the bottom and showed the highest degree of deformation, and created our 3D surfaces from that, which we can see here. And the advantage of that is that we can see a lot of details, what kind of deformation is actually going on, and to get an overview of how these folds may have formed and how they are located in the ice dynamic setting, we need 2 main informations, which is the orientation of the fold axis and the direction of overturning of the folds. So the 2 questions are how these folds have formed in this region, and if they did form under the current ice dynamic setting. And I would like to leave that for a discussion, and for that I have prepared these 4 images which show in A the whole ice dynamic setting with the surface velocities and flow lines. On image B we have a zoom in of that region. On image C we see the bed topography, and on image D we have additional information about the basal properties. For example, if basal water is absent or present, we see that it's absent. And we have data from a paper from McGregor for basal melt rates, so if we have melting or freeze-on at the base. And we have data from Leisinger-Vielli et al., who calculated an index if the bed is likely to be frozen or unfrozen. And yeah, thanks for your attention.